Hi, this is Mrs. Myers, and today we're going to go through the review sheet for the tests 3.1 through 3.5. This should say 5. We skipped 3.4. A plane parallel to plane SUQ. SUQ, SUQ, the plane that contains that is here. So a plane parallel to that would be the other side. So this side of the box, which is maybe plane, we only need 3 letters, so plane TRV. Two lines that are parallel to line RV. Well, here's line RV. Parallel to that would be any of these that are standing straight up. So QU, SW, any of those. What was this one, TX? 3 lines that are skew to WX. Here's WX. It's going left to right. We need something going top to bottom or front to back, not on the same plane. So we have to go maybe RV and QU, or QS and TR. Two lines that are parallel to plane QUR. So now instead of a parallel plane, we're looking for parallel lines. Parallel to the plane QUR. QUR is this back plane here. So parallel to that back would be either ST, WX, any lines that are in the parallel plane will be parallel. So anything from this front, ST, TX, any of those. SW, WX, any of those. Okay, in the following exercises, describe the statement as true or false. If false, explain why. Also state their intersection points if possible. So AE, line AE, and line BF are skew lines. AE and BF are skew. That's false because they're parallel. Number 6, plane DBF and plane ABD are parallel. Remember, these 2 lines here mean parallel, so plane DBF, that's the right-hand side, and plane ABD, that's the top. Are they parallel? Nope. Sorry, false. So that would be because they're actually perpendicular to each other, like the floor and the ceiling, right? GH parallel to EF, GH parallel to EF, that is true. FH parallel to AC, FH parallel to AC, that's true actually, because they could be connected through diagonally. Plane EFH parallel to line GC. Plane EFH is the bottom, parallel to line GC. GC. Nope, not parallel, so that's false. And they're actually perpendicular also. FH and CD are skew lines. FH and CD are skew lines, that's true. H, CD, true. It says if false, state their intersection points. So let's go back and see about the intersection points. For number 5, well, there's no intersection because they're parallel. Number 6, plane DBF and plane ABD, their intersection is going to be this line right here, BD. And the only other one is number 9, which says plane EFH and line GC. EFH, so their intersection is point G. Point G. Okay. I'm going to put up these answers and come back to you. Okay, so let's look at some of these answers here, 11 through 15. 6 and 8 are corresponding angles if you look at these C and D as being parallel. 7 and 11 are alternate interior. Again, this time we're actually going this way. A and B are parallel. 10 and 14 are actually vertical angles. Nothing needs to be parallel there. 5 and 10, same side interior angles if A and B are parallel. And 2 and 5 are linear pair. Those don't need anything for being parallel. Number 16, angle 3 is vertical to the 132-degree angle. Angle 5 is corresponding. Angle 7 is alternate exterior. Number 17, measure of angle 1 is 50 degrees because it's a linear pair with the given angle. And measure of angle 2 is 130 because it's corresponding. Over here we have angle 1 is alternate interior with 76, and angle 2 is same side interior, so supplementary with 119. Number 19, this is the equation you should write. Since these two lines are parallel, these look like same side interior angles, so they add up to 180. And then you solve there. And then number 20, since these two lines are parallel, these two angles are corresponding angles. So they are set equal to each other. There's the solution there. Okay, so let's look at this proof. We're given that both sets of lines are parallel here. A is parallel to B, X is parallel to Y. So all of our angle relationships will apply here. So we state our given, then we say 15 and 9 are alternate exterior angles. Here's angle 15, here's angle 9. So based on these two lines being parallel and B being our transversal, 9 and 15 are alternate exterior angles, and we're just stating them for what they are. So that's definition of alternate exterior angles. Then we say they're congruent by the theorem. Then we say their measures are equal by definition of congruent. Now again we're stating 9 and 4 for what they are. They're same side interior angles. This time A and B being parallel. That's just by definition. Then we say they're supplementary by the theorem or postulate. Measures add up to 180 by definition of supplementary. Substitution, we took out the 9, replaced it with the 15, because right here we said that they're equal, so we can replace them with each other. Now we could just say they're supplementary because of the definition of supplementary. Okay, error analysis. Here they have this diagram. These are alternate interior angles, so they need to be set equal to each other since alternate interior angles are congruent. Here they have them adding up to 180, which is not the correct way to do that one. Factor the following polynomial. Okay, you might want to use the box method here since it's got a number out front in front of the x squared. So we'll put our 5x squared here and our negative 2 here. Then multiply those together, we get negative 10x squared. That's being 5x squared times negative 2. And then we take our middle term and we put it down here. Now we're trying to think of what multiplies together to be negative 10x squared and adds to be negative 9. So 10 and 1, negative 10, and a positive 1. So we're going to put our 1x here and our negative 10x here. Now GCF between these two is just 1. Greatest common factor between these two is 5x. Now we'll go the other way. GCF of these two is x, and of these two we have to use the negative here, negative 2. So factored, this is just 5x plus 1 and x minus 2. And we could check this by multiplying it out. 5x times x is 5x squared, which is what we have here. 5x times negative 2 is negative 10x plus 1x. That gives us our negative 9x. And then positive 1 times negative 2 is a negative 2. So that's our last term there. So here is our factored form. Okay? Okay, so given the following information, if we know L is parallel to M, Then we're given angle 1 and angle 7, and these are alternate exterior angles, so I know they're congruent to each other, so I can set them equal. Here's my equation. It has an x squared in it. This is why we need our factoring. So we're going to get everything to one side, add x to both sides. X squared, negative 7 plus 1 is negative 6x, and we'll subtract 7 from both sides and get everything equal to 0. Now we can factor. I actually don't need my box method here. You can still use your box method, but since there's just an x squared out front, I know this has to be x and x, and I know the last terms have to multiply to be negative 7 and add to be a negative 6. So I'm going to use negative 7 and positive 1, and so my x value is whatever makes this equal to 0, which is negative 1, and whatever makes this equal to 0, which is 7. So my value of x is either negative 1 or 7. I have to check to see if these both work in my equations, because we don't want negative angle measures. If I plug in negative 1, I get negative 1 squared is positive 1, plus 7, that would be 8. If I plug in negative 1 here, I get a positive 8 again, so that checks out okay. Negative 1 works. 7, if I do 7 squared, I get 49 minus 7 times 7 is 0. That doesn't work. That doesn't work. Can't have a 0-degree angle in this situation. So our only solution is actually the negative 1. Okay, here we are going to take this diagram and decide if it's yes or no. Here, these are marked parallel. So is 1 congruent to 2? Yes. Why? Because they're corresponding angles. Number 26, these are not marked parallel. They don't even look parallel. So is 1 congruent to 2? No, because not parallel. Not parallel lines. Number 27, they are marked parallel. Angle 1 congruent to angle 2? Yes, because they're alternate exterior angles. Let's call it the theorem. That's really our reasoning. Corresponding angles theorem. 28, angle 1 congruent to angle 2. They're corresponding, but they're not marked parallel, so no, not parallel. 29 is 1 congruent to 2. These are marked parallel, so yes, alternate interior angles theorem. And number 30, do they add up to 180? No, not parallel. So we can't assume that those same side interior angles add up to 180. Here, if they're telling us that angle 1 is congruent to angle 2 now, the question is, are these parallel? Yes, they are parallel by the converse of the corresponding angles theorem. Remember, whenever we're concluding that the lines are parallel, that's the converse of. Okay, and angle 1 congruent to angle 2. Is AB parallel to CD? Not necessarily. These are just vertical angles. Vertical angles do not help us conclude that lines are parallel. Okay, in these problems, you're going to be finding the value of x. Come back and check your answers. Okay, so check these carefully. Value of x for part A, these would be set equal to each other because they are alternate exterior angles. Part B, they would add up to 180 because these are same side interior angles. Part C, these would add up to 180 because they are a linear pair. Part D, these would be set equal to each other because they are alternate interior angles. Okay, and 34, we have to add these three things up and have them equal 180 because the three angles of a triangle add up to 180 by the triangle sum theorem. This one comes out to a decimal, 9.8. 35, we can use linear pair to get x is 50. Then, since we know this is 50, these two angles are the remote interior angles. So by the exterior angles theorem, 4y plus y equals 50. And so y is 10. And then 36, again, just the exterior angles theorem says this one exterior angle equals the sum of the two remote interior angles. So add these together and we'll get 140 x is 22. Okay, these last few problems here. What values of x would make the lines parallel? These two are same side interior angles, so we just do 180 minus 117 and we get 63. 38, these are same side interior angles, so again they have to add up to 180, so we solve for x, adding them up to 180. And 39, these are alternate exterior angles, so we have to set them equal to each other and we solve for x. Okay, very good.